as for the upcoming speaker, we'll be hearing about a very specific topic, and that says understanding how to prepare your balance sheet for growth by using debt and AI. We'll be hearing it from Peter Findley, the Chief Executive Officer from Anchor Block Technology. Let's welcome him on stage.
Hi, everybody. I'm Peter, and I'm CEO of Anchor Block. Before running Anchor Block, I was a senior portfolio manager at BlackRock, and I also have a degree in artificial intelligence from Stanford. After basically managing money at BlackRock in sort of a high level, you take a look at it and you ask yourself, what exactly is driving sort of the growth here, and how do we make sure that we get AI to actually help people, right? Just because you buy something and it goes up, that's only so useful. So the question is then, how do you actually use AI to get to basically a situation that is actually useful for your business? And basically the way you get to how to use your AI to get to a situation is really comes down to your balance sheet, right? Because AI is about data, and in the data, it's really your data. And what do you do with your data, right? And basically, if you don't have your data in a good balance sheet structure, then it's very difficult to enhance it, right? Because you want to think about your business, that if your business basically is starting to scale, right, what is going to happen to your AI, and what basically are things that you can put on your balance sheet? Now, what is going to go on your balance sheet is not necessarily just data, right? Because you have to think that AI is not just all about data, right? So AI, to some extent, it needs, call it degrees of freedom to work with, right? So you have to think about, as you build up your balance sheet, to start to allocate basically things that you might not know about, right? So what you want to do is essentially when you are building up your balance sheet, you want to take a guess as to how to fill things in, and you want to think about basically debt and equity essentially as ways of scaling your business. Because when you use basically encapsulation of various costs and things like that, it allows you to basically split your funding needs into both debt and equity. And one of the most important things is you basically can think about debt essentially as short-dated participation in the upside from equity, right? So there's a term structure, and it's important to essentially match your assets and liabilities. And within that, basically you can use the essentially AI, but the AI that you're using might not be, for example, ChatGPT, right? So so basically what you want to do is you want to think about on your balance sheet, what makes up your current costs, what makes up your current revenues, and then the only reason you're using AI is because you want to scale your business, right? What's the point of doing AI if your business isn't going to go up, right? AI is about scalability and efficiency. So when you're using AI, you can think about things such as your costs, right? So what I like to do is when I'm looking at a business, I try to think, supposing their revenue goes up 10 times, right? What happens to the balance sheet, right? Because it's not just what happens to your balance sheet now, because again, you're doing funding that's not necessarily overnight. You have longer duration funding. And so you should assume that your balance sheet is going to change, and it might not react the same way under certain sizes as it does as you start to scale up. So then as you start to scale up, basically, you think about your costs, right? So you have different types of costs. So when you're inputting your data as part of your balance sheet, you want to basically estimate not just what is it right now, but suppose the business succeeds. What does it look like? And an example would be, for example, customer service. So if your revenue goes up 10 times, the odds are you probably have to have 10 times as much cost on customer service. Now, you probably don't have 10 times as much cost on your technology expenses. So you want to think about basically your balance sheet in terms of what's a linear expense that'll scale up with your revenue, and what's a nonlinear expense that will basically not scale with your revenue. And that's going to be technology and other things. And then as you go into your balance sheet and you start to segregate these things, you can basically take the things that are going to scale up with your revenue, because you assume that if you get additional dollars of revenue, you're going to also have these additional costs. And so this is going to give you a net return, basically an IRR, that is less than you think, because you're going to have these costs that scale up. But if you're aware of this beforehand, you can basically arrange for your funding to make sure that it matches these things so that you can basically start to scale up the business. So what we like to do is we essentially want to figure out how can we take a look at your data to help scale it up. What are the costs that are going to be good in terms of both the linear versus the nonlinear? And then what is the true return on the assets and the lending? For what it's worth, if you're not making at least 4% a month, you probably will not clear your costs as you scale. So the hurdle of basically what it takes to make money as a lending business can actually be quite high. And so this is part of, if you look at what's going on globally, this is something that's happened as people's input costs have gone up because they had too much leverage, and as a result, they basically cannot raise prices on customers enough, so you have to start with the appropriate thing. So you want to take a look at basically what is your true return, and that's where you use basically AI and analytics. But I want to talk actually a bit more now on sort of what AI do you use? Right. This is a very important thing, and I'm probably just going to spend the rest of the time talking about this. And also, if anyone has questions, please feel free to interrupt me. So when we're taking a look at sort of what goes into AI, there's two types of AI. There's essentially large language models, which is ChatGPT. ChatGPT is useful for some things, but if you look at your balance sheet, and your balance sheet does not include text, for example, and it is primarily numbers, it is unlikely that ChatGPT on its own is going to significantly enhance your business. It might save you some costs and things like that, but ChatGPT is not going to tell you what to do. That's something that's very important. There are other models, though, that you can use. So the idea is that once you have analyzed your balance sheet, you can find the correct model that will enhance your revenue and your specific model the most. Because there's a large number of options that are out there. And so one of those things could be as simple as a recommender system. A recommender system might analyze a customer, basically a small business's inventory, and do something like, all right, if I am stocking 30 products, it's as simple as cluster analysis, where you essentially want to take a look at what I'm stocking and make a suggestion. If I stock this one additional product, my revenue should go up because every person that has purchased these other 30 products normally purchased this one additional product. So if you have input everything, then basically you can get predictive analytics that'll tell you what you probably want to stock and what you don't want to stock. And keep in mind, this does not come from ChatGPT. Now, if you want to get something from ChatGPT, that could be to help minimize your linear costs, if you go back to what I said before. So if you are running your customer service through a call center, it is a linear cost. It will scale with your revenue. That is not ideal. If you then shift it to technology, and then it is ChatGPT, then it will not scale with your revenue. And basically, as your revenue goes up, your operating margin goes up. And that is where we want to see a business get to. Because as operating margins go up, it means everyone pays you back. And basically money is made. So that's incredibly important. But I want to talk a little bit about basically also what is the power of AI, because I don't think we've really talked about that and what has really happened in the past 5 years. So I'm sort of going to leave the debt side a little bit right now and just sort of talk about the evolution of what has happened in AI so people really understand sort of what the orders of magnitude of basically picking the wrong model means for you. So if you look at sort of call it the brain size of AI in 2017, let's just say it was a unit of 1. There was this revolution called the transformer model published by Google then, which is essentially when AI really started to evolve. If you look at basically the progress of all of AI from 2000 until 2017, so 17 years, that's like, let's just say that moved 1. The amount that AI has improved between 2017 and now is somewhere between 200 and 2,000 times as powerful as it was in 2017. So if you are using a model that was trained and built in 2017 and you are not using something new, you might be up to 200 to 1,000 times worse than someone using a state-of-the-art model. So it becomes really important to pick what is the model, and also how do you determine what makes this model useful. And so that comes down to two things. One is the data, right? So you want to take a look at what was the model trained on, and does this data map to your types of data? Because oftentimes, when you are starting off in a business, you don't have enough data. So what you need to do is you need to bring in publicly available data or a model that was trained on something that is similar. Because either you use the data or the data is already embedded in the weights, it still ends up being roughly the same thing. So if the data is very relevant, so an example would be Instacart. Instacart basically has published a large number of basket analysis, right? That is not necessarily sitting inside of ChatGPT. ChatGPT is primarily using something called the pile. That is a collection of basically web crawling. This is not something that is going to understand basically basket analysis. If you ask ChatGPT, I am stocking diapers and milk, what else should I stock? It'll give you an answer, but it may not be the best answer. So you want to think about basically within your data, so that's start with the balance sheet, figure out your data, and then try to figure out how do you get the most powerful model to use that. So right now, ChatGPT, so just you can actually use numbers here. So in 2017, the number of parameters in a model was 100 million. Right now, ChatGPT has 20 billion. So it is 200 times more powerful than the models basically in 2017. There is a direct correlation between the number of parameters in a model and its intelligence. If you think of parameters in a model, it's roughly equal to the IQ of basically the model. Now, something with a high IQ but basically no data doesn't really know anything. So when someone is born, when a human is born, they have an IQ, but they don't know anything, right? It's not, they have to be taught. So you need a model that both has a high IQ and also relevant data. And so ChatGPT, again, is 200 times. It has 20 billion parameters. There are, however, numerous other models that are out there that are actually much larger. For what it's worth, the background of ChatGPT, it's been around for about 2 years. It just hasn't been publicly released. So the state of the art right now in AI is probably 5 times more powerful than ChatGPT. What ChatGPT, though, is ChatGPT took basically a smaller sized brain and trained it on a very specific set of data designed to be conversational. So ChatGPT, even though it is 1/5 as powerful as some of the larger generalized models, is trained on specific data that actually helps it be more effective. This goes back to the point of the data, right? So ChatGPT is 200 times more powerful than models from 5 years ago, but 1/5 as powerful as the state of the art. So, but the state of the art was not necessarily as tailored to the models that basically ChatGPT is. So you want to ask yourself then, what can you use? Because maybe you don't need all the power from ChatGPT. Maybe you just want to use the power of AI on your phone, right? In which case you want a smaller model, because the problem with these parameters is there's a direct correlation between the size of the parameters and the hardware required to actually run it. So if you want to deploy AI to the masses and have someone be able to use it on the phone, they can't actually use some of these large-scale models. This is why we ended up with basically smaller models. So if you looked at the state of the art in AI 2 years ago, it was all about how do you build a bigger and bigger model, more parameters. They actually have a model that has 540 billion parameters. By the way, if you want to put this into context, if the human brain has roughly 1 trillion parameters. So if we want to see what artificial generalized intelligence looks like, it'll happen around 1 trillion parameters. So we are not there. We're basically at 20 billion. So of basically customized training. So it's still a significant way to go to get to generalized intelligence. However, it's not like it's that far away. So it's just something to be aware of, that there are some of these incredibly large-scale models that are out there, and you can use them for your business. And it's important to know that they're out there. In addition to ChatGPT, there's actually open source alternatives. One of the biggest problems with ChatGPT is that you don't own your data. You're using an API, you're sending it to the cloud. It's not secure. You can't run it locally. There are open source solutions that are actually just as good that were released a few months ago that actually I would recommend people use instead of ChatGPT if it is something you are concerned about in terms of data protection. And I think when it comes to using banking, I think that's actually important. The idea that you're gonna run a ChatGPT model and you're a bank and you're gonna basically upload all of this and just assume they're not gonna peek at your data, you don't want to assume that. You'd like to use something that you can own and run locally. And so you can find a model that might be able to do the equivalent of what you were getting from ChatGPT that is open source or smaller, more efficient to run, and may not have all the things from ChatGPT, but it still gives you all of the power that you're looking for. But it might be something that you can then deploy. There are models that do work on people's phones right now, but they take specific things and they have to be tailored a specific way. But if you have basically spent the time in the beginning to identify what your data is and how to basically scale with it, then you can pick the correct model. I want to open up, do people have any questions right now? Or does anyone want me to talk about any more of the specifics of any of the state-of-the-art models or what various companies are working on for this? Because what happens is that the quality of the models of AI, the model from Google, the model from Apple, the model from OpenAI, they inevitably actually all end up being about the same. So rather than using someone else's proprietary model that they're wrapping, you're better off using your own in the long run. So unless you want to basically just get back to where we started, where Google basically is taking all of your data and using it for ads, and they're the ones making all the money. If you then pass all your data to these APIs, you're going to end up in the same situation. So being able to own your own data and own your own model in the long run has lots of value, because eventually all of these models will become commoditized. The difference in the performance of these models between each other is not very large. They're all very good, is essentially the conclusion. All of these models are very good and they're getting a lot better. Now it's just a question of, can you deliver these models efficiently to consumers so they can actually use them? Because one of the biggest problems is that a lot of these models, again, they cannot run on someone's phone. And so it requires connectivity. And part of that is a function of basically the parameter size. But you want to figure out what is the right model, how many parameters, and be very cognizant that you are using a big model. So if you can't identify the number of parameters in a model, odds are it's small. So if you're using a model that has 15 million parameters, by the way, there's a lot of people doing that. There's the most efficient model is called a Roberta model, and that is a very small model that can run on people's phones. It has 17 million parameters. As compared to ChatGPT, that is not a very intelligent solution. So what happens is if you look at the output of some of these models that doesn't have a lot of parameters, it won't be as good. And likewise, if you took ChatGPT and you actually went from 20 to 100 billion parameters, which is what they actually have behind the scenes, the ability to toggle between that to get to their larger models, you can actually see the output meaningfully improve. So sometimes if you're looking at something and you say, AI hasn't serviced me well, it might be because the model you're using isn't the right model, or it just doesn't have fundamentally a large enough brain. So the goal is find the right model and make sure it's a big enough brain, because what you don't want to do is basically lose because you just picked a small brain. Right? Because someone can just come along with the exact same data and just pick a bigger model, and the AI will be better. So you don't want to basically get beaten by someone just because they picked a bigger model, especially when you can know this beforehand and identify what the correct model is to use. Any questions? Okay. Thank you very much. And if anyone wants to talk further, or anyone here wants to talk more technical details, I'm pretty actively involved in the research community from Stanford and amongst other things still. So I don't want to get into too many technical details here, but I'm always happy to geek out with anybody if they want to. Thank you.